All right, what's going on, everybody? Today we're doing another LeetCode problem. This one's called binary search. It's an easy, so let's get into the problem. We're given an array of integers nums, which is sorted in ascending order, and we're given an integer called target. They want us to write a function to search for that target value among the values in the nums array. If the target exists, they want us to return the index where it's located. Otherwise, they want us to return -1. And our algorithm must be big O of log n runtime complexity. So basically what they're getting at is they want us to write binary search, if you couldn't already tell from the title. And basically, yeah, so anytime we have a sorted array, binary search is pretty relatively low code complexity. We can whip it up pretty quickly, and it's extremely fast. Log n is much faster than linear time complexity. And just to emphasize that, if we were to search for this value 9 in this nums array with a linear algorithm, we'd only be decreasing the search space where the answer could be by -1 with every iteration of our algorithm, because we would just be looping, checking every single element. That's just pretty slow. With log n time complexity, we know the array is sorted. We can basically just have some pointers and a midpoint and just say, okay, is the target less than or equal to our midpoint? If it's less than, then we only have to search this side of the array now, therefore decreasing the search space where the answer could be by a factor of 0.5, or cutting it in half with each iteration of our algorithm. So basically, when you keep cutting something in half repeatedly, it's way faster than just chipping at it little bit by little bit. So hopefully that kind of makes log n runtime complexity more understandable, why it's so good and so fast. But basically, yeah, let's just get into the algorithm here. And this is not even really optimal solution. I mean, they really want us to write a binary a binary search algorithm for this problem. So the solution is going to be to implement binary search, and then obviously the runtime for that is going to be what we were discussing. So that's that big O of log n. It's extremely fast. This search space gets cut in half with each iteration. So let's see that in action. So I'm gonna go just step through the algorithm in pseudocode with this example before I get into the actual code, just so we can kind of see what's going on. So what's happening? Here we go. Okay, so I'm gonna come this out. I'm gonna use this array. So this is going to be the nums array, and then the target is going to be 2. We're going to want to keep track of a few things. So in terms of variables, so we're going to want a left pointer. That'll be 0 at first. We'll want a right pointer. That'll just be the last index in our array. So at first that'll be 5. I almost started writing code there, but yeah. So at first that'll be 5. We also want a midpoint, and we're going to continuously update that based on our left and right pointers, and the formula for that is just going to be our right pointer minus our left pointer divided by 2, and plus our left pointer. So yeah, so let's loop through this. I might put a little more space here. So really just going to be updating these variables. So the first thing we're going to do is update our midpoint. So since the midpoint is right minus left divided by 2 plus left, remember this is going to be an integer because we need a midpoint that's an index between these indices. Thankfully in C++, that's going to happen automatically with integers. So integer division, it truncates anything after the decimal. So we'll have a right minus left. That's going to be 5 divided by 2. That'll be 2.5. We truncate, so that'll be 2 plus left is 0, so it'll be 2 at first. So basically our first value we're looking at is going to be this 3 here. So we're going to ask, is our target equal to the value at this midpoint? No, it's not. Okay, is it greater than that or less than that? Well, it's less than that, so we can set our pointers to be our new right pointer. Instead of being 12, we only need to search this half of the array now, because it's a sorted array. We know it can't be up here the target is less than that midpoint, so it's got to be down here. So our new right is going to be the old midpoint minus 1. So that's going to be 1. So we're already looking at a much smaller array here. But we still need to update our midpoint now. So for the next iteration, so now we're going to go into the next iteration. The midpoint is going to be right minus left. That'll be 1 divided by 2. That's 0.5. We truncate, so it'll just be 0 plus 0. We're going to get 0. So the midpoint here will be 0. We're going to be looking at minus 1. And let me just verify. So 1 minus 0 divided by 2 is going to be 0.5 plus left. Yeah, so that's 0. Okay, just double checking because that seems a little weird, but that is what we're going to be doing. So, this is the algorithm. So with that new midpoint, we're looking at minus 1. Is our target equal to the midpoint? No, but it's greater than the midpoint, so we only have to look at values that are above the midpoint now. So our new left pointer is going to be the old midpoint plus 1. So our left pointer will become 1 now. So we're going to go into the next iteration of the code. So our new midpoint is going to be 1 minus 1. That's 0 divided by 2. That's 0 plus 1. That'll be, so our new midpoint will be 0. And or our new midpoint will be 1, excuse me. So the value there will be 0. So we're going to ask, is target equal to 0 again? No, it's not. Is it greater than 0 or less than 0? It's greater than 0. So we only need to search for values on the right side of 0. However, notice something's going to happen here because we're going to be moving our left pointer since we're going to the values that are now greater than that midpoint. But notice that our left pointer has actually passed the right pointer. Now that's an illegal condition, so our loop is going to break. And at that point, we know we haven't found the answer, so we'll just return, we're going to return minus 1 here at the moment that happens. Technically, it would try to do the loop again, and it would say, oh, right is, we can see that left is greater than right now, so it would stop. So anyways, we return minus 1 there. So that's an example where the solution, or where the target value is not found in the array. But let's just get into the code here. So we're going to have that left pointer. We're going to have the right pointer. Remember, it's going to be equal to the last index in that array. So we can just take the size of the array minus 1. And we're also going to have a midpoint, which I'm not going to set until we get into the loop. So we're basically going to loop while the right pointer is greater than or equal to the left pointer. And then we're going to update our midpoint. So we're going to use that formula. It's just right minus left divided by 2, and then plus that left pointer again. So then we're going to basically ask, is our target equal to the element that is at that midpoint? If it is, then we can literally just return the index of that midpoint. So that's the case where we found the answer. Now, if we didn't find the answer, we need to see, okay, how does target compare to the value at that midpoint? So if the target's greater than the value at that midpoint, then remember, we want to set the left pointer to be equal to the midpoint plus 1. And then there's only one more case now, and that's going to be an else if. There's only one more case now. That's if the target's less than the value at that midpoint, but this is kind of implicit. This is the only remaining possibility here, so we don't need to actually code in the query for that. We know the target has to be less than num's midpoint at this point. When that's the case, the right pointer can get set to the midpoint minus 1. So that's pretty much it for the code. This is the case where we return the answer. If the answer is here, it is guaranteed this line of code will be reached. Otherwise, we can just return minus 1 if the target is not present in the array whatsoever. So hopefully this explanation of the problem helped you understand it better. Let me just fix these bugs real quick. Hopefully there's not too many. But yeah, hopefully this video helped you understand the problem better. If it did, be sure to leave a like, subscribe, all that stuff. So peace. See you on the next.